For more than a decade, the Interstellar Boundary Explorer (IBEX) mission of NASA has been investigating the boundary region between the heliosphere, also known as the bubble, surrounding our solar system and interstellar space. Before we get into what's gone wrong with NASA's Interstellar Boundary Explorer, let's explain what it is and what it's used for. The heliosphere, which is created by solar winds, functions as a shield against the radiation that is emitted from other stars that are the most intense. IBEX is an initiative that is being led by the Southwest Research Institute, SwRI, which is located in San Antonio, Texas. They claim that the one and only objective of the mission's research is to gain a better understanding of the global interaction that exists between the plasma of the solar wind and the interstellar medium on the periphery of the solar system. The IBEX spacecraft was sent into orbit on October 19, 2008, from the Marshall Islands, using a Pegasus rocket that was released from an L-1011 aeroplane. Up until the launch of IBEX, the Pegasus could only ever launch spacecraft into a low Earth orbit. Despite this, IBEX was able to circumvent Earth's radiation belts and enter orbit thanks to its onboard propulsion system as well as an additional solid rocket engine. The IBEX spacecraft is so small that it only has room for two pieces of scientific equipment, which have been given the names IBEX High and IBEX Low. This apparatus, which is in the shape of a donut, is utilized in the process of tracing the origin of negatively charged, high-energy particles. Both the IBEX High and Low sensors have the ability to detect uncharged particles. However, the IBEX High sensor will only pick up on particles that meet a certain minimum energy requirement. These particles, which are created when charged particles in the solar wind grab electrons from the cold neutral gas ions that are a component of the matter and radiation that floats around in space, are known as energetic neutral atoms, ENERs. The spacecraft completes a rotation of the solar panels on its exterior at a rate of 4 times per minute while it is in orbit around the planet. This helps to ensure that the panels always face the sun in the same direction. IBEX High and IBEX Low are oriented in a direction that is perpendicular to the solar panels, which enables them to collect neutral atoms in a consistent manner throughout the entire year. When the satellite rotates, each instrument has the opportunity to collect ENERs from a variety of different angles. After that, the IBEX research team constructs a comprehensive map of the locations of particle birthplaces. After leaving Earth's atmosphere, the spacecraft entered into a series of elliptical orbits around the planet, during which it spiraled slowly. But this brought IBEX within the gravitational pull of the Moon, and the Moon's little tug altered IBEX's orbit, which made it unstable. This brought IBEX within the Moon's gravitational pull. IBEX deviated from its spiral path in 2011 in order to adjust its trajectory so that it would travel further away from the gravitational pull of the Moon. At the moment, it takes IBEX 9.1 days to complete one orbit around the Sun. NASA anticipates that IBEX will be able to maintain its data collection mission thanks to its stable orbit for many years to come. On March 2nd, the spacecraft's controls were finally reprogrammed after the crew had disregarded NASA's instructions for the previous 3 weeks. During the course of its orbit around the galaxy, the solar system as a whole does not move physically through space. Between the stars is a region known as interstellar space, which is full of various gases and particles. The solar system is surrounded by a bubble-like region known as the heliosphere. This region is kept clean by a phenomenon known as the solar wind, which carries charged particles away from the Sun and pushes against this gas. The termination shock boundary can be found inside the heliosphere, and it completely encircles the Sun and the other planets. We have arrived at a limit of the Sun's influence when solar wind particles begin moving at a rate that is slower than the speed of sound. The diameter of the shock at its endpoint varies in magnitude according to the force exerted by the solar wind. In the region known as the heliosheath, which is located between the termination shock and the heliopause, solar wind particles are compressed and become turbulent when they make contact with the interstellar medium beyond the heliopause. The heliopause denotes the point at which the solar system transitions into the interstellar medium and serves as the limit of the protective sphere of influence that the Sun exerts. Only 2 spacecraft have been able to survive the termination shock up until this point. Both the Voyager spacecraft, 1 and 2, were the ones to break the barrier in 2004 and 2007, respectively. The Pioneer 10 and 11 satellites were the first spacecraft to make it to the edge of the solar system. New Horizons will be the second mission to do so. Because the distance to the termination shock is always changing, we are unable to determine with absolute certainty when the ship will pass through the barrier. The heliosphere is shaped more like a teardrop than a perfect sphere, and it has a tail that resembles a comet that trails behind it as the Sun moves across the Milky Way. The side of our solar system that travels ahead through space in the opposite direction of the motion of the Sun is known as the tail, and it extends further into space than the side that travels behind it. IBEX, on the other hand, demonstrated that the heliosphere's tail section does not continue on for nearly as long as was previously believed by scientists. A NASA spacecraft has finally returned to normal operations after experiencing issues in space for several weeks. The Interstellar Boundary Explorer, IBEX, of NASA worked together with mission controllers on March 2nd to perform a computer reset, according to statements made by agency officials on Monday, March 6th. This signaled the end of 3 weeks of unsuccessful attempts to communicate with the spacecraft. The mission crew was forced to perform an external reset, also known as a fire code reset, in order to retake control of the unresponsive spacecraft. This occurred 2 days before IBEX was scheduled to perform an autonomous reset and power cycle on Saturday, March 4th. In addition, representatives from the agency emphasized that everything was back to normal now. The telemetry collected by IBEX demonstrates that the spacecraft is in good health and performing as intended. Interstellar Boundary Explorer was sent into space by NASA in October 2008 with the mission of studying the heliospheric boundary, also known as the bubble, that separates the solar system from the rest of the galaxy. The spacecraft spent the first year after it was launched compiling an exhaustive map of the heliosphere and taking photographs of the entire sky every 6 months. The most important thing that the instrument discovered was a concentrated area of particles known as the IBEX ribbon. The spacecraft itself is healthy, as the agency emphasized when it first disclosed problems in regaining command capability in late February, despite the fact that the computer on IBEX unexpectedly reset, which caused the mission to be forced into a mode of contingency planning. On February 24th, NASA officials reported that flight software still is functioning and that all systems on board the spacecraft appeared to be operating normally. They also stated that all systems on board the spacecraft appeared to be operating normally. In order to gain a better understanding of the heliosphere and the role it plays in determining how our solar system is shaped, Spacecraft such as IBEX are studying both the Sun and the solar wind, which is the consistent stream of particles that comes from our Sun. After a total of 15 years spent in space, the spacecraft is still operational even though its primary mission was completed in 2011. This is more than a decade after the primary mission was completed.